Hello guys, very good evening and welcome to Prep Funda. This is Sanjay Rathi. How are you guys? Now, this is a very important session on Thevenin's and Norton's theorem with the dependent sources, right? And that is important for electronics, electrical and instrumentation branch, and it is a part of network navigator, that is your guide to network concepts. Okay, तो यहाँ पर हम लोग डिस्कस कर रहे हैं very important numericals with concepts, and you will get the command over the topics with what numericals, and I am going to cover this time Thevenin's and Norton's with important questions. Okay, are you ready? So let me know that sound quality, picture quality, everything is fine. Everyone please join the session now. Yes please. Well, give me 1 minute. Is it everything is fine? Okay then, I think now everything is fine. Then guys, this is a network or circuit theory through questions, Thevenin's and Norton's theorem with dependent sources. And that is my introduction. Myself Sanjay Rathi, 24 years of teaching experience, and I have qualified and selected for engineering services exam. These are my ranks in engineering services exam: AIR 16 in ESE 2005, AIR 21 in ESE 2008, and I have trained more than 1 lakh students for these competitive exams. Right? अब थोड़ी सी ड्यू टू ऑनलाइन क्लासेस एंड सो ऑन, तो जो कंटेंट है, गुड कंटेंट्स आर अवेलेबल टू यू, तो उसका यूज कीजिए. और अभी काफी टाइम है, तो अपनी प्रिपरेशन स्टार्ट कर दीजिए फॉर कॉम्पिटिटिव एग्जाम्स लाइक व्हाट गेट और इंजीनियरिंग सर्विसेज और अदर एग्जाम्स लाइक HPCL. दिस सेशन इज इंपॉर्टेंट फॉर ऑल कॉम्पिटिटिव एग्जाम्स. हाउ आर यू भानु प्रकाश? वेरी गुड आफ्टरनून. Then this is my channel Electronics by Sanjay Rathi, where I will upload the PDF of all these sessions, as well as if you want notification and if you get any idea about the questions or what you want to clear your doubts, then you can join this channel Electronics by Sanjay Rathi. Link is given in description. Go through my channel, that is Prep Funda, subscribe it, and you will get that idea about the link, guys. Okay, and I am going to share all the important links with you. Right, already I have started network. Then after that I'm going to start what analog, and I'm taking one important course on analog, that is what paid courses on analog. If you want detail, then write in comments, I will share the link with you guys. Okay, so already I have started the course for analog. Then, and that is the series, guys. Okay, now today I am discussing what Thevenin's and Norton's theorem with dependent sources. Tomorrow I am going to discuss what two-port network, then two-port network, hybrid parameter and ABCD parameters, then what first order transient with RC circuit, then RL circuit, and after that next week, it depends upon your response, I am going to take what steady state analysis of sinusoidal signal and what power factor, how to calculate the power factor and so on, right? Okay. That's why Bhanu, first of all already I have started with what basic subject, network. Once you will get the basic idea about that network, then I'm going to start with what analog. Okay, and if you want to join, anyone want to join morning classes 6 to 8 paid classes or interact with me in systematic manner with PDFs, questions, previous year questions, booklet, then yes, you can join. Fee very nominal. For fee and all other structure, you can comments me, I will share the comments, I will share the link with you. Okay, then if you are interested, then a comprehensive course, that is what analog, electronics, and that's just a demo lecture already available in this. 2 lectures are available with one is what basics of the diode, second one is what ideal and practical diodes with numericals. To go through it, it is a recording of what paid classes, so how the paid classes is going on, and how I'm going to explain each and everything, and what is the difference between the free classes and paid classes. You will get the idea from that. So that is available in the same channel. Go through it and watch today 2 lectures, basic electronics and basics of the diode, and second one is ideal and practical diode with what numericals. Okay, so this is a comprehensive course. And now guys, in last class I have given you the idea about what Thevenin's and Norton's theorem. Thevenin's means any network with linear network can be converted into a single voltage source and one RTH. So this is the case. So Thevenin's theorem states that any two-terminal linear network having a number of voltage, current sources and resistance can be replaced by the simple equivalent circuit consisting of a single voltage source in series with resistance. Okay, last time I have given. Similarly, Norton's theorem states that any two-terminal linear network with current sources, voltage sources, resistance can be replaced by an equivalent consisting of a current source in parallel with a resistance. What is the meaning of this? Suppose you have any linear network, then this is the Norton's equivalent, this is called Norton's current, and this is called Norton's resistance, and that is the load. This terminal is A and B. So we are finding across A and B, when we are looking from A and B, that particular linear network is converted into that. Similarly, you can convert it to single voltage source and resistance. That is called Thevenin's equivalent. So in last class already I have explained what is the VTH. VTH is nothing but open circuit voltage across A and B. And what is the IN Norton ISC, short circuit current? When we are making it short, this is the. And what is the RTH or RN? Both are equal. VOC upon ISC. VOC upon what? ISC. Okay. So this is called RTH or RN, and these two are source transformable pair. Source transformable pair means if the Thevenin's is known, you can find the Norton's. If the Norton is known, you can find the Thevenin's. Because what is the IN is equal to VTH upon RL, RTH. And what is the RN is equal to RTH. So if you have the idea about the Thevenin's, you can find the Norton's. If you have the idea about the Norton's, you can find the Thevenin's, IN into RN. And what is the RTH? RN. So this is the source transformable pair, and that is we are finding for any linear network. Okay. Now, are you ready to solve some numericals? So I am going to solve some important numericals. Ask your friend to join the session. Share the link in your group. Right. And first of all, subscribe channel, like the session, so that you will get the notification about all coming classes, guys. Don't miss it. बहुत ही important session मैं लेने वाला हूँ, right? और आपकी language भी आप मुझे quote कर लेना, in which language you are comfortable, right? Because I have to take some session in English and what some session in Hindi plus English, okay? जहाँ भी आपको लैंग्वेज का इशू है या कुछ भी है तो आप बताइए. if you find any difficulty in any topics, then please inform me. Okay then. Now first question, this is with what? Dependent sources, guys. This is with dependent sources. That one dependent source is given as 10ix, 4 ohm, 2 ohm, 1 ohm, Norton equivalent seen at terminal AB of the given circuit. What is the Norton equivalent across this? You have to find Norton's equivalent. There is a one dependent sources 10ix, 4 ohm, 2 ohm, 1 ohm. If you want to solve question with what? Without independent sources, then English plus Telugu you want, Bhanu Prakash. Okay. I have some idea about the Telugu only. Okti, Rendu, Mudu, Nalgu, Aidu, Aru, or and Midi Padi. I think I missed one alphabet and I can write like this only. Yes. I think this is my name. है ना? So that is only this much, not more than that. Okay then. So Norton's equivalent seen at the terminal AB of the given circuit. This is 10ix, 4, 2 and 1. So what we have to find? How we can find? First of all, if the dependent source is given, then what is the method to find the RTH? What is the method to find the RTH, guys? First of all, you have to take what? A battery of 1 volt here. A battery of 1 volt here. or you can take 1 ampere current source, it's up to you. You can take, this is called test battery. First of all, connect here, and if there is any independent sources, any independent, right, for example voltage source or current source, if it is voltage source, make it short circuit. Independent, I am talking about the independent sources. Voltage source, make it short circuit. Current source, make it open circuit. But note here, these two are independent. Independent, right? To make it 0, and if RL is given, make it what? Infinite. Remove the RL, and then finally this is the A and B. Connect a 1 volt battery, let this is the current I. Then RTH will become, or that same RN will become 1 upon I. We have to find this 1 upon I to make it. So already there is no dependent sources, so no dependent independent sources, so independent sources already 0. Now this is, we have to find the 1 by I. Now watch this, how we can find the 1 by I. I is coming here, this is Ix. So what is the current here? I minus Ix, KCL. Incoming current I, outgoing is Ix. So what is the outgoing? I minus Ix. Now you can write a KVL from this point to this point, right, to get the idea about the Ix, or you can also write the KVL in this loop, right? So it's up to you. Then you will write -1, KVL -1 plus I, this is the 1 into I, plus 4 times of I minus Ix, 4 times of I minus Ix plus 10 Ix is equal to 0. Now this is I plus 4I, that is the 5I, minus 4Ix plus 10Ix. Check my calculation, this is the 5 is equal to 1. What I am doing, I am just finding the value of Ix, guys. Value of Ix. So what is the value of the Ix from this? Now this is the 6Ix. 1 minute. Get the equation. This will become 5I minus 6Ix is equal to what? 1. 5I minus 6Ix is equal to what? 1. Now we have to find the 1 by I. So 1 by I, how we can find? Write down the KVL in this loop. Only in this loop. Write down the KVL in this loop. When I am going to write, you will get 4 times of I minus Ix, 4 times of I minus Ix plus 10Ix, and then this is the plus, this is minus, and that's why it will become minus 2Ix is equal to 0. Then this will become 4I minus 4Ix plus 10Ix minus 2Ix is equal to 0. So अब यहां से देखिए रिलेशन, व्हाट इज दिस? 4 minus 2, दिस इज द 4Ix. दिख रहा है? व्हाट इज दिस? दिस इज द 4Ix is equal to minus 4I. So what is the relation between Ix and I? Ix is equal to what? Minus I. Now you can put here in this equation, this is the equation. If you are going to put the Ix is equal to minus I, so minus minus it will become plus. Minus minus it will become what? Plus, and it will become 6 plus 5 11. क्या ऐसा है कुछ, या कहीं पर देखो जरा कुछ आंसर मैच हो रहा है या कहीं पर कैलकुलेशन मिस्टेक है? टेल मी गाइस. फाइंड द वैल्यू, फाइंड द वैल्यू. कैलकुलेट इट. ओके, चेक कर लेते हैं जरा. ओके देखो यहां पर देखो 5i प्लस ये देखो ये है कैलकुलेशन मिस्टेक, दिस वन. 5i plus 6ix is equal to 1. So ix is equal to what? Minus I. Now put here minus I. then it will become 5i minus 6i is equal to 1. So minus I is equal to 1. So what is the 1 by I? 1 by I is equal to minus 1. So, and that is the answer for Thevenin's resistance. That is the answer for what? Thevenin's resistance. So what is the method to find the Thevenin's resistance? So calculation, that is the, I have corrected it, because from this equation to that equation, it will become 5i plus 6ix. Then write down the KVL in this loop. When I am writing the KVL, you will get this equation and finally this one. Put here and find the 1 by I. So first of all, for any network, can we get the negative resistance, RTH or RN? Yes, we can get the negative resistance. Then if suppose we are getting the negative resistance, what is the meaning of this? So that is the RTH minus 1 ohm. First of all, I will solve this question. And then what is the Norton's current? So when I have to find the Norton's current, I have to make it what? Short circuit. I have to make it what? Short circuit. Now there is only independent sources. There is no independent sources, and that's why if suppose you are going to write a KCL at this point, suppose you are going to write the KCL at this point, what is the value of ISC? ISC will become Vx upon 1. Right, that is the Vx. Now how we can find the Vx? Vx minus 10Ix. Vx minus 10Ix upon 4 plus Vx minus 0 by 2, that is Vx upon 2, this is the Vx minus 0 by 2, Vx minus 0 by 1, just I am writing the KCL. And what is the 10Ix, guys? What is the Ix? Vx upon 2. Put here, you will get Vx minus 10 into Vx by 2 upon 4 plus Vx by 2 plus Vx by 1 is equal to 0. Now this will become, you can take Vx as a common, right? So it will become 1 minus 5 upon 4, then already I have taken 4 plus 1 by 2 plus 1 is equal to 0. This is constant, this is Vx, so this is not 0. Definitely what is 0? Vx is 0. Vx is what? Equal to 0. This is not a 0. Minus 1 plus 1, 1 by 2, and that's why the Vx will become 0. Means if there is no dependent sources, guys, if there is no independent sources, then what is the value of the ISC or VOC? That is 0. So which answer is correct? 0 and minus 1 ohm. 0 and minus 1 ohm, and that is the correct answer for this. And is it possible to get the negative value of resistance? Yes, negative resistance is possible, because if you are having the negative resistance, for example in this question we are getting the negative resistance. What is the meaning of this? In any numerical, if you are getting the negative, for example you are getting the VTH and here you are getting the negative resistance minus 1, or here you are going to connect the RL, right? Let it be 2 volt. VTH is 2 volt. So what will be the output voltage? Right, what will be the output voltage? For example, it is, right, it may be 4 volt, 4 ohm. So according to voltage division rule, the voltage across the RL will become VL, RL upon RL plus RTH, this is RTH, into VTH. So what is the RL? 4, what is the RL? 4, what is the RTH? 1, minus 1, into VTH 2, so you will get 8 upon 3. You will get 8 upon 3, and that is greater than what? 2 volt. That is greater than what? 2 volt. In this case, we are getting the amplification. Or if it is a positive resistance, if for example the RTH is positive resistance, let this is the 4, this is the minus 1, and this is the VTH 2 volt, then what will be the output? 4 upon 1 plus 4 into a VTH. What is the VTH? 2. You will get 8 upon 5, and definitely it is less than what? 2 volt. So this is the attenuation, and that is what? Amplification. So negative resistance means it may be the equivalent circuit of any amplifier, okay, and output voltage or output current may be greater than, there is the amplification, and that is the concept of what? Negative resistance. Okay, is it clear? I think that point is clear to you. Okay, so if you are new to this channel, then subscribe our channel, because that channel is new but I am not new. Okay, so on different channels, on different platforms, number of videos are available, you can watch there, but in this channel, if you suggest me, sir, take this topic, so that is our channel, that's why I can arrange session according to me. कोई टाइम लिमिट नहीं है, कुछ भी जैसा भी आपको टाइम सुटेबल है. सजेस्ट मीन्स क्या आपको चाहिए, कैसा आपको चाहिए, किस में प्रॉब्लम आ रही है, नेटवर्क में है, एनालॉग है, और कंट्रोल, डिजिटल, एनी सब्जेक्ट, राइट. तो वी विल ट्राई टू अरेंज सम इंपॉर्टेंट सेशंस फॉर यू, बट नॉर्मली ट्राई टू सॉल्व व्हाट नंबर ऑफ न्यूमेरिकल्स, so that you will get the idea, right, and variety of numericals, some questions from standard textbook, somewhat from previous year question paper, and don't try to mug up. If you find any difficulty, then inform us, okay, कि सर ये concept समझ नहीं आ रहा है, तो is there is any other method, तो ये तो देखिए, for example in this question we are getting the negative resistance because there is no independent sources, and that's why what is the Norton's current? 0. So that is the reason. -1, yes, it is possible. So EDC and analog na, yes, just after that, just after next week I will arrange an analog session. Okay then, अब आते हैं next question पर. ये देखो, what is the Norton equivalent seen at the terminal AB of the given circuit? If suppose you are going to solve this 5 to 6 question, automatically you are going to get the command over Norton's. Tell me, Norton's equivalent seen at the terminal AB of the given circuit. AB of the given circuit. Use your copy, pen, calculator. If suppose you are watching the recorded lecture, not live, then pause the lecture, pause the session. First of all, try to solve and then go through solution. Okay. Follow. Norton's equivalent seen at the terminal AB of the given circuit. 10 volt, 4 ohm, 5 ohm, 2 Ix. Then now, yeah, these are the options. Norton's equivalent seen at the terminal. Please take a screenshot whether it is A, B, C or D, or you can also put your answer here. Draw the diagram, try to solve it, right. Now, first of all, very easily you can say which answers are not correct. First, if you want to find the resistance, what is the rule here? Thevenin's resistance or Norton's resistance? Just all independent source 0. So what about this 10 volt battery? Independent. Make it what? 0. How is it possible? Make it what? Short circuit. So make it what? Short circuit. And then find resistance at this point. Then find resistance looking from A and B. First of all, you can apply a 1 volt battery, but remember in this diagram, suppose I am going to make it short circuit, that this is the short circuit and that is the ground. So what is the voltage across the 4 ohm resistor? 0. So if the voltage across the 4 ohm resistor is 0, so what is the value of the Ix? 0 by 4, 0. Okay. Now this is a current controlled current source. So with the Ix 0 means what about this? 0. Or if it is a current source, if it is 0, then it will act as what? Open circuit. Guys, it will act as open circuit, it is short circuited. So what is the figure here? A and B. There is no need to apply the 1 volt battery and so on. It is directly, it is looking at what is the resistance seen from A and B. So RTH or RN will become what? 5 ohm. RTH or RN will become what? 5 ohm. So that is the case. So this is the case, 5 ohm we are getting resistance. So 5 ohm, which answers are not correct? This is not correct, this is not correct. So this is a MCQ. So now out of these two you can choose any one. Now next one, how to find the Norton's current. I will also find the Thevenin's resistance, Thevenin's voltage. Now, just to find the Norton's current, you have to make it what? Short circuit. And that is the ISC. You have to make it what? Short circuit. That is the ISC. Now, what is the value of the IX? This is reference. This is the 10 volt, and that's why IX will become very, very simple. 10 is fixed. When we are finding the ISC, then you can't make it what? 0. 10 is fixed. 10 divided by 4. And it will become 2.5. IX will become 2.5. So what is the 2IX will become? 2IX will become 5 ampere. Register in ohm, then current will be in ampere. तो ये आ गया आपका 5 ampere. Now, first of all, solve it. Then you have to find the ISC. How we can find? For example, this is the 5 ampere current is coming here. At this point, ISC. So what is the current at this point? 5 minus ISC. 5 minus ISC. Okay, already you have idea about this. This is the 2.5. You have this 2.5. Now, can we apply the KVL in this loop? We can apply the KVL in this loop. When I am going to apply the KVL, you will get the idea about the ISC. This will become 5 times of 5 minus ISC plus 10 is equal to 0. 25 minus 5 ISC plus 10 is equal to 0. 35. Check my calculation now. Minus 5 SC is equal to 0. So what is the ISC is equal to 35 by divided by 5. I am getting the 7 ampere. Is it correct? Check कीजिए calculation. Because answer is 0.2 ampere or 5 ampere. चलिए calculation check करते हैं. Calculation check करो जरा. 10 divided by 4, that is what? 2.5. 2.5 into 2, that is 5. Oh, हाँ, और कहाँ गलती है? अरे मैंने किया है, आपको बताना है जरा. क्या है आंसर? RTH 5 ओम तो आ गया. इसमें बताओ ISC क्या होगा आंसर? देखो ये 10 है डिवाइडेड बाई 4 तो 2.5 आ गया. ये तो बिल्कुल सही है. 10 डिवाइडेड बाई 4 दैट इज द 2.5 और 2 टाइम्स उसका हो गया 5. वो भी करेक्ट है. फिर उधर से हम आते हैं तो ISC आपका करंट चला गया 5 माइनस ISC. इधर चला गया करंट. यहाँ पर लगा रहे हैं KCL. इधर से आया 5. इधर चला गया ISC. इधर आएगा 5 माइनस ISC. ये भी करेक्ट है. और हम फिर यहाँ पर हमें करंट की ज़रूरत ही नहीं है तो आपने लगाया KVL. यहाँ आ जाएगा प्लस माइनस 5 इंटू 5 माइनस ISC. ठीक है भाई. प्लस 10 वोल्ट. ओके. एंड देन 25 प्लस 10 35 माइनस 5 ISC. कैलकुलेशन तो ठीक है. ओके. और ISC इज इक्वल टू व्हाट? 7 एम्पियर मे बी. तो चेक कर लीजिएगा कैलकुलेशन. मतलब कॉन्सेप्ट यही है कि आपको क्या करना शॉर्ट. अब मैं बोलूँगा अरे सर आया कि नहीं आया सही, क्या ये वाकई सही है या गलत, तो कैसे चेक कर सकते हैं? हमारे पास RTH है, हमारे पास ISC आ रहा है और ISC नॉर्टन इक्विवेलेंट में मान लो आंसर मैच नहीं कर रहा. कोई बात नहीं. क्या हम इसको वेरीफाई कर सकते हैं? हम एक काम करते हैं, VOC निकाल लेते हैं. What is the VOC at this point? What is the VOC at this point? Open circuit voltage. क्योंकि VOC अपॉन ISC क्या होता है? RTH. VOC अपॉन ISC RTH और you can say ISC is equal to VOC upon RTH. तो open circuit voltage मतलब this is the Thevenin's voltage. Now this is the 2IX. So what will be current here? 2IX. Now this is the 2IX. What is the current going here? IX. Right. What is the current here? 2IX. So what will be the current through the battery? 0. Okay. Now find the value. Find the value of VOC. Find the value of VOC. Then watch this. This is the, you can apply to, if you want to find the current, what is the current given by the battery, you can apply the KCL at this point. This is the IX, this is the 2IX, this is the 2IX, and you will find that I is equal to what? IX. Now VOC, you can apply the KVL here. VOC. So you can write here minus VOC, this is the minus VOC, plus 5 into 2IX, that will become 10IX, plus 10 is equal to 0. Okay. Then what is the IX here? 10 divided by 4. Divided by 4 plus 10 is equal to 0. Then it will become VOC is equal to 100 divided by 4 plus 10. So it will become 25 plus 10, 35 volt. VOC is 35. So what is the ISC? VOC upon RL or RTH. 35 divided by 5, that is the 7 ampere. Again we are getting the same answer, right? तो क्रॉस चेक कर लो, वैल्यू समझ लो और एक डिपेंडेंट सोर्स के हिसाब से आप वैल्यूज निकाल सकते हो. तो ये देखो यहां से वेरीफाई हो गया, यहां से हमारा आ रहा था. ओके. तो हो सकता है ऑप्शन या डायग्राम में कुछ प्रिंटिंग मिस्टेक हो, लेकिन बात ये है कैलकुलेशन आप चेक कर लीजिएगा. मेथड क्या है ये इंपॉर्टेंट है. तो ये हो गया 2 आंसर. नाउ अब आते हैं नेक्स्ट उस पर. नेक्स्ट क्वेश्चन है, इस तरीके से आप VOC भी निकाल सकते हो, ISC भी निकाल सकते हो, डिफरेंट मेथड्स. अब देखिए जरा इस क्वेश्चन को आप लोग कैसे बनाते हो. एंड दैट इज द क्वेश्चन हियर. द नॉर्टन्स इक्विवेलेंट सर्किट ऑफ द सर्किट इन द फिगर एट टर्मिनल AB इज, वेयर इज द टर्मिनल AB? A और B यहां है. दिस इज द AB, दिस इज द IX 8 ohm, this is the 4 ampere, this is the 2 ohm, 3IX, 24 volt. Now tell me, the Norton equivalent circuit of the figure at terminal A and B is, क्या होगा? If you want to find the Norton's equivalent, first of all, for resistance, dependent sources, independent sources, this will open circuit and that will what? Short circuit. Make it what? Open circuit, make it what? Short circuit. And then apply a 1 volt battery and then try to find it. So what is the method here? Watch. First of all, make it open circuit. Independent source is 0. I am going to find the Norton's resistance. Open circuit. Then make it what? Short circuit. Short circuit. 24 volt battery is short circuit. Okay. Then it is a 2, or you can also convert this current source into what? Voltage source also. Yes. Because it is not depend upon this, so you can also convert it, right? Are you getting the 7 ampere ISC? Yes, so I am also getting the 7. Good. देखो IXC, IX. Now first you can connect, or directly you can connect a 1 volt battery here, because there is a dependent sources. Suppose I am going to connect the 1 volt battery and let this is the current I. So what is the VTH? What is the RTH or RN? I will also explain the second method. 1 upon I. Then how we can find the I? So at this node, try to understand what is the incoming current I. And this is also the same node. Now suppose this is the node A, so this is also the node A. So what is this? Outgoing current. This is the outgoing current. So can you find this current? I dash. So write down the KCL at A. KCL at A. What is the incoming current I? What are the outgoing currents Ix? What is the outgoing current 3Ix? And what is the outgoing current I dash? This is the I dash. Watch this, I dash. Right, to Ix, 3Ix, I dash, and that is equal to what? I. Now guys, what is the Ix? Ix is nothing but 1 divided by 8. Watch this, 1 divided by 8. 1 volt battery divided by 8 ohm, so 1 by 8. So here we can write I is equal to 4Ix. I is equal to 4Ix plus I dash. So you can put here I is equal to 4 into 1 by 8 plus I dash, and you will get I is equal to 1 by 2 plus I dash. Now that is a one equation. That is a one equation, very simple one. We have to find the 1 by I. Now you have to write a KVL here from this point to this point to this point. KVL. So when I am writing the KVL, it will become, this is the minus 1 volt. This is minus 1 plus 2 I dash, all are 0, is equal to what? 0. Now what is the I dash from this? I minus 1 by 2. I dash is equal to I minus 1 by 2. Right here. It will become minus 1 plus 2I minus 1 is equal to 0. 2 divided by 2. What is the 1 by I? What is the 1 by I? 1 ohm. What is the 1 by I? 1 ohm. We are getting. Watch this. Is there any answer? 1 ohm is the answer here. 1 ohm. So you have to find the I. तो I will verify with the other method, लेकिन यहाँ से पता चल रहा है आपको 2I is equal to 2. तो what is the 1 by I is equal to 1? One ohm. Right? Now अब आता है what is the Norton's current. Now guys, to make the Norton's current means short circuit current. You can make it what? Short circuit. I will also find the VOC, but first of all Norton's current directly make the short circuit. When we are making it short circuit, that is the reference, this voltage is become 0. So what is the value of the Ix will become? Ix will become 0. 0 by 8, that will become 0. Now this Ix is 0, okay, so that's why this 3Ix is also become 0. So this will act as what? Open circuit. This is 0, open circuit. Now what is the voltage at this point? 0. Right, this is a open circuit. What is the voltage at this point? 24 volt with respect to ground. So can we apply KCL at this point? Yes, we can apply the KCL at this point 0, 0, because these all are in one node. So what is the outgoing current? ISC. What is the outgoing current? Plus 4. What is this? 0. What is the outgoing current? 0 minus 24 by 2. This is the outgoing current. 0 minus 24 by 2 is equal to 0. Now this will become ISC plus 4 minus 24 by 2, 12 is equal to 0. 12 minus 4, 8. What is the ISC? Is equal to 8 ampere. I am getting 8 ampere. Check my calculation. So just I have written what? This one. So what is the answer here? 8 ampere and 1 ohm. B is the answer. 8 ampere and 1 ohm. हाँ सूरज, how are you? as so everyone, that is my new endeavor. Okay, or in this channel, according to your suggestion, I can arrange session for you, or what we can arrange important session, important numericals from the textbook, previous year question. It's up to me. So please suggest me what you want, then I will try to arrange all those sessions, guys. Ultimately, guys, we have to increase the percentage, because only 17% or 18% students are ready to are able to what qualify the GATE examination. Then what is the problem? तो पर्सनल इंटरव्यू नहीं है, पर्सनल गाइडेंस चाहिए. इफ दे हैव सम पर्सनल प्रॉब्लम दे कांट आस्क. बहुत सारी छोटी छोटी बातें, किन से बात करें, क्या प्रॉब्लम आ रही है, बेसिक क्लियर नहीं है, कॉन्सेप्ट क्लियर नहीं है, बिंदास बात करो, टेलीग्राम चैनल पर आओ, है ना, इलेक्ट्रॉनिक्स बाय संजय राठी. तो इस तरीके से हम लोग धीरे धीरे इम्प्रूव करते हैं, और अभी हमारे पास टाइम है तो छोटी छोटी बेसिक चीज़ों को समझते हैं. तो ये हो गया 8 ओम एंड 1 ओम. नाउ अब और इज देयर इज एनी मेथड? तो share the link of this session, and everyone first of all subscribe it. Ask your friend to subscribe and give me suggestion. Okay. Now how we can find the VOC? Suppose if you want to find the VOC, just to verify it whether we are getting the right answer or wrong. VOC means what? VTH. So at this point it is VOC, means this is also VOC. This is VOC. And what is the IX will become VOC by 8. IX will become VOC by 8. Now write down the KCL at this point. Directly you can write the KCL. So you will write, what is the outgoing current? 4. What is the outgoing current? IX. What is the outgoing current? 3IX. Right, this is the VOC. So IX 4 3IX, and what is the outgoing current? VOC minus 24 upon 2. VOC minus 24 upon 2 is equal to 0. Now, what is the VOC? VOC is nothing but 8 times of IX. From this, so you can replace VOC by 8 times of IX. So it will become 4 plus 4IX plus, what is the VOC? 8 times of IX minus 24. This is divided by 2. This is divided by 2 is equal to 0. So it will become 4 plus 4, 8IX plus 4 minus 12 is equal to 0. And then 8IX is equal to 8. What is the IX is equal to? 1. No need to find it, because VOC will become 8 volt, right? Now what is the ISC? What is the ISC? VOC upon RTH or RN, 8. And what was the RTH? Already we have found, first of all, 1 ohm divided by 1, 8 ampere. Same answer. 8 ampere 1 ohm. Agar if it is VTH is asked, then 8 volt. What is the RTH? 1 ohm. Source transformable pair. So I am solving question on Norton's, but it is a Norton's or Thevenin, same type of questions we are getting on dependent sources. Okay. So देखो अभी how many questions I have solved? 3 questions with different methods. Now next question on dependent sources. If suppose you want to get command over any topic, try to solve what? 5 to 6 questions. So automatically you will get command. Now watch this. The Norton's equivalent circuit of the circuit. Norton's equivalent. कोई बात नहीं, Norton's निकालो, Thevenin's निकाल लो. So sometimes we have to use the basic concept here. We have to find the Norton's equivalent across A and B. This is the 2 ohm resistor, this is the 6 ohm, this is the 2 ohm, this is the 4. Across the 4 ohm we are having the Vx. Across the 4 ohm we have the Vx here, and that is the 5 ampere. Okay. Now if it is 5 ampere, if you have any voltage, if you have any resistance parallel to what? Voltage source. Watch this. Across this, is there is any dependent sources? No. in a previous question there was a ix, but here there is a no dependent sources, so you can remove it, ignore it. You can ignore it because it is connected parallel to that. Second thing, if you want, for example, if you want to calculate the, now you, if you want to, first of all remove it, then if you want to calculate the RTH or RN, then make it what, 5 ampere current source 0. 5 ampere current source, if you want to make it what, 0, you can remove this, then this is open circuit because it is a current source. No need to consider it because it is parallel to a voltage source. And then if you want to find the RTH, you can apply a 1 volt battery here and I here. Okay, 1 volt battery here and I here. Now what is the voltage at this point? Vx. What is the voltage at this point? 2Vx. Vx. What is the voltage at this point? 3Vx. Directly from this point to this point, 3Vx. Okay. Then we have to find the 1 by I. 1 by I. Now, what is the current here? This current will become 3Vx upon 6. That will become Vx by 2. This current will become Vx by 2. So what is the current here? I minus Vx by 2. Because this is the Vx by 2. So what is the current here? I minus Vx by 2. Same current will flow here. I minus Vx by 2. Now can you find what is the Vx is equal to 4 times of this? So Vx is equal to 4 times of the I minus Vx by 2. Then you can write Vx, right, by 4, this is the Vx by 4, is equal to I minus Vx by 2. This side, Vx is common, 1 by 4 plus 1 by 2 is equal to I. So I think it will become what? Bolo, 3 by 4, yes. And Vx is equal to become 4 by 3 times of I. 4 by 3 times of I, Vx. तो अब यार निकालना क्या है ये ध्यान रखो ना, कितना निकाले हो VOC 8 volt. Now this is 1, this is 3Vx, and 3Vx is what? If it is the 4 by 3I, so what is the 3Vx will become? 3 multiplied, so 3 cancel, 4I. So voltage at this point is 4I, voltage at this point is 1 volt. Can we write a relation between this? Yes, easily you can write an equation. What is the I is equal to? 1 minus 4I upon 2. 1 minus 4I upon 2. This 2 is here, this will become 2I is equal to 1 minus 4I, and that will become 6I is equal to 1. 6I is equal to 1. What is the 1 by I? 6 ohm. So according to my calculation, I am getting the 6 ohm. According to your calculation, what is the answer? According to my calculation, I am getting the 6 ohm. So only in one option we are having the 6 ohm. In first option. If this calculation is correct, then what is the answer? 6 ohm. So what is the method here? Just first of all remove this 5 ampere current source, all the independent sources 0. Second, this resistor is connected parallel to what voltage source, that's why I can remove it, 2 ohm. And then second thing, remove this, so this will become 2Vx, and then make the diagram again. This is the current because the voltage at this point is 2Vx, voltage at this point is Vx. So what is the voltage at this point? 3Vx. So what is the current here? 3Vx by 6, so Vx by 2. And then write down the KVL. And again that 4Vx will become I minus Vx by 2 into 4. वहाँ से लिख दिया और calculation and arrange it. You will get the answer. No need to write the KVL. Okay. तो ये आया, चेक कर लीजिएगा 6 ओम. अब आते जरा इसी में इसी क्वेश्चन में 1 मिनट, इसका डायग्राम नहीं है क्या? ओके, हाउ टू फाइंड द ISC और VTH? And then after that I will give some assignment. Wait for that and try to solve and give me answer on comments box or what. Now watch this diagram. Then again, first of all, if you want to find the VOC, then remember again you can remove this 2 ohm resistor because it is connected parallel to that current voltage source. It is not a current source, it is a voltage source. You can remove it. And then again this time, because there is no current, what is the meaning of the open circuit? No current here. And that's why this voltage will become VOC. And that is the reference. So from this point to this point, if you are watching, this is the Vx. So this VOC is nothing but 3Vx. VOC is nothing but 3Vx. From this point to this point, it is a 3Vx. Okay. Then this is the 5 ampere, right? Watch. Again, VOC by 6. What is the current here? VOC by 6. VOC minus 0 by 6. So VOC is 3Vx. 3Vx by 6. So it will become again Vx by 2. If this is there is no current. Remember, there is no current from this branch. And we are getting the Vx by 2 current here. Right? So this is the same current is flowing from this Vx by 2. Because there is no current. The same Vx by 2 will flow like this. So this is the Vx by 2. Here we are getting the 5. So what is the current here? 5 minus Vx by 2. 5 minus Vx by 2. This is the Vx by 2, or here it is a 5. Outgoing current is Vx by 2. So what is the current here? 5 minus Vx by 2. You have to find the Vx only. So what is, you can write the equation. So what is the Vx is equal to? Vx is equal to 4 times of 5 minus Vx by 2. Multiply it. 20 minus 2Vx. That will become 3Vx is equal to 20. So what is the Vx is equal to 20 by 3. What is the VOC is 3Vx, and that's why it will become 20 volt. Very simple. 20 volt. So what I have done, first of all, make it what? Open circuit. Then this current is 0. This is the VOC. It will become what? 3Vx. 3Vx by 6. That is the Vx by 2. Same current will flow like this. 5 minus Vx by 2. What is the current here? 5 minus Vx by 2. Every KCL on the diagram, directly you can write Vx is equal to 4 times of that, and you can find the Vx, you can find the VOC. 20 volt. 20 volt. Suraj, I go to remove the resistance will be 0. How to prove this? Suraj, I will prove it. 20. Right? I'm just going to prove it. 20 volt. Okay. Now VOC is 20 volt. Suppose anyone want to, already we have got what? ISC is equal to what? Resistance is 6 ohm. Now, if you want to find ISC, ISC is nothing but VOC upon RTH. What is the VOC? 20. What is the RTH? 6. So 20, that is the 10 by 3 ampere. This is the answer A. So from Thevenin's you can find, or otherwise if you want to find the short circuit current, then again 1 minute. If you want to find the ISC, and I will prove it, है ना? 1 minute, give me 1 minute कि कैसे 0 होगा, क्यों लेंगे, उसको भी proof कर देते हैं. Now again this is the diagram. If you want to find ISC, short circuit, always write down the KVL. I am removing it. Right, this is the Vx, and again this is the 2Vx, this is the Vx, then it will become what, 3Vx. Directly you can write. Okay, or otherwise if you find difficulty, then you can choose it as a V2, like this is the V1. So what is the V1 is equal to Vx, right? And what is the relation between V2 and V1? So you can write V2 minus V1 is equal to 2Vx. This is the V2 minus V1 is equal to what, 2Vx, and that's why V2 will become 2Vx plus V1. Therefore, what is the V1? Vx. That's why it is a 3Vx. Already I have calculated. Now I round down the KCL. This is called supernodal analysis. Simultaneously at these 2 points, because we have the relation between V2 and V1. So simultaneously this is called supernodal analysis. Now what is the outgoing current? V2 minus 0 by 2. Watch this. We have to find a V2. V2 minus 0 by 2. V2 minus 0 by 6. Now at this point, V1 by 4. V1 is nothing but Vx. V1 by 4. And then what is the incoming current? 5 ampere. Incoming is equal to, all are the outgoing current, so incoming is equal to outside 5 ampere. So V1 by 4, or simultaneously at these two nodes we are writing the KCL. This is called supernodal. Now what LCM you can take? This is the LCM will become 12. It will become 6V2, 2V2 plus 3V1 is equal to 5. What is the relation between V1 and V2? V1 is nothing but Vx. So this is the V1 is nothing but Vx. So 3V1. So what is the V1 is equal to? V2 by 3. So you can write here V2 by 3. So 3 cancel. So this will become 6V2 plus 2V2 plus what? V2 by 3. So 3 cancel. So V2 is equal to 60. So what is the V2 is equal to? 6 plus 2, 8 plus 1, 9. So 60 by 9. 60 by 9, that has become 20 by 3 volt. 20 by 3 volt up to this point. So what is the ISC? V2 by 2. ISC will become V2 by 2, 20 by 3 divided by 2, answer 10 by 3. Same answer we are getting? Yes. Same answer we are getting. From different method we are getting the same answer. So that is the case, guys. So directly you can find the VOC, RTH, then you can use, right? और ये आ गया. Otherwise what we can do, तो ये हो गया आंसर. This is the answer. Already I have verified. I have find a VOC, ISC, RTH and so on. Then how we can prove this? How we are going to remove? Suppose you are not going to remove this. Suppose if you don't want to remove, just we are wasting our time. How? For example, at this point voltage is what? V1. At this point let the voltage is V2. Okay, first of all write down the nodal at this point. Suppose you are going to write down the nodal at this point, right? Then nodal at this point, and always remember, if there is a voltage source we have to apply what? Supernodal analysis. So first equation will become V2 minus V1 is equal to 2Vx. V2 minus V1 is equal to 2Vx. This is the first equation, right? Or already it is because of dependent sources we can say V1 is equal to Vx. Second, okay. So the V2 minus V1 is equal to Vx. Now write down the supernodal, and how that is the, if we are considering the 2 ohm, then first of all start from this. What is the incoming current? 5 ampere. What are the outgoing current? V1 minus 0 by 4. V1 by 4. Watch this. V1 minus 0 by 4. V1 by 4. Then you will write, if suppose you are going to consider it, V1 minus V2 by 2. V1 minus V2 by 2. Already we have considered this voltage source. V1 minus V2 by 2. Then nodal at these points. V2 by 6. V2 by 6. What is the current here? 0, because we want to calculate the VOC. VOC is nothing but V2 because there is no current. But we are writing the KCL. So what are the outgoing current? This is the outgoing current. This is the outgoing current. This is 0. And this is the outgoing current. And what is the IZ? IZ will become V2 minus V1 by 2. V2 minus V1 by 2. So simultaneously we are applying the KCL. We are applying this to node. So at this point we are writing the V1 minus V2 by 2. At this point we are writing the V2 minus V1 by 2. So what about this term? Cancel out. When directly we can write, if suppose we are neglecting it, what we can write? What is the current? 5. Incoming. What is this? V1 by 4. Now directly at here V2 by 6. Tell me guys, same equation we are getting, Suraj. Same equation we are getting, that is cancel out, and again we are getting the same equation. So is there any need to consider the 2 ohm resistor? Is there any need? तो जरूरत नहीं पड़ती, because if the voltage at this point 2x, so what is the voltage at this point? It is remain 2Vx, independent of the resistor. Independent of the resistor, whether it is a 2 ohm, 3 ohm, 5 ohm, 10 ohm, the voltage across this will remain 2Vx. That's why no need to consider it. No need to consider it. Okay. Then hope. So do you want to solve some questions? This is the assignments for you. But try to solve, right, the Thevenin's equivalent for the, if you have the answer, then you can send your screenshot on my Telegram channel. I will check, I will go through it. So the Thevenin's equivalent for the below circuit is, what is the Thevenin's equivalent? 10 ohm, 20 ohm, 0.5 V naught, that is given. You have to find the Thevenin's equivalent. There is only dependent sources. There is no independent sources. So already I have given you the idea, right? Already I have given you the idea. If we are asked the current through ohm, then the answer will be 0. Means which current? Current. If you ask the current through the 2 ohm, no. There is a current. There will be current, guys. If suppose the power dissipation across or anything is required across the 2 ohm resistor, then you have to consider it. But we want voltage here, we want current here, that's why we are removing. Otherwise, if suppose what is the current through the 2 ohm resistor, it is asked. If what is the current through the 2 ohm resistor, it is asked, then you have to find the 2Vx upon 2, that is the current. Right? If suppose this is the resistor, what is the asked? Suppose it is asked what is the current through the 2 ohm resistor, then definitely it is I is equal to what? 2Vx by 2. But if suppose you want voltage or current across any other resistor, across any other component other than what? 2 ohm, then no need to consider 2 ohm. Are you getting my point? That is important. If suppose the power dissipation across the circuit is asked, then you have to find the power dissipation across the 2 ohm resistor. Okay. Today I have already solved. I have one question where the dependent source depend upon that resistor. So again you have to consider it. But in this question, if we want VOC, there is no relation between VOC and 2 ohm. We want ISC, there is no relation between ISC and 2 ohm. Because if suppose the 2 ohm is present or not present, or any other ohm is present, this voltage will remain same 2Vx. That's why no need to consider it. If the current is asked, then you have to consider it. Okay, so that is the first assignment. Try to solve this and then give me a suggestion if you want to solve this type of question, guys, and that is the second one. Tomorrow I will solve these two questions, and guys, I am going to start with what? Two-port network. Two-port network with. So stay tuned with us, guys, and if you want any other suitable time, then yes, you can ask me evening classes or so on. So tomorrow, two-port network, Z and Y parameter. Very, very important one. Normally we are getting question. After that, next session is two-port network with H and ABCD parameters. Then first order transient RC circuit. Okay. And then first order transient RL circuit. So that is the schedule for this week. We have the 4 session 1, 2, 3, 4. Stay tuned with us. Day will remain same, right? And time depends on you. Okay then. So this is about topic. Subscribe our channel. That is the session, two-port network, Z and Y parameters, network circuit theory. The question, please note the time and date tomorrow, 4 p.m. Try to attend the live session. This is my Telegram channel, Electronics by Sanjay Rathi, where I will upload this PDF. Okay, so you can download it, go through the question, try to solve it. And guys, finally, thanks. Subscribe the channel, share the link of this session and like the session. Thank you very much. Have a nice day.